So I was interested in perception and contrast, in this particular case color contrast. Researching simultaneous contrast specifically. Simultaneous contrast refers to the way in which two different colors affect each other. The theory is that one color can change how we perceive the tone and hue of another when the two are placed side by side. Simultaneous contrast is a phenomenon that happens when two adjacent colors influence each other, changing our perception of these colors, more or less saturated, more or less bright. It can be observed both with different hues, luminosities. As I researched, I came across a YouTube video by Derive and Matisse, an artist named Merv Moriarty, giving his interpretation of simultaneous contrast. It is his opinion to make a good decision in picking a color to use against a color, or in other words a color surrounding another color, to get the most beautiful effect from a color you have deemed unattractive. In this case a rather unattractive, yucky, greenish, drab, brownish, with yellow tendencies, wanting to break through, though it leans drab green. I've recreated the color as best as possible in the first figure main, Fig. 1. I agree with him when he talks about what colors are potentially in this color. As he puts it, what does that color want to be if it is going to turn itself into a more beautiful, purer version of itself? What is potentially in it? I immediately thought yellow. He states that yellow is where it wants to go. I was thinking a hue of golden yellow specifically. But then I immediately disagreed with him when he said that two things needed to be done to make the color more beautiful. But maybe I am just more fond of the color than him. He said to make the color more beautiful, the color needed to be lightened. I found that plausible but questionable. He notes that is where yellow is most vibrant. He also states the color needs pushed towards its yellow end. In other words, pushing it by adding another color surrounding it to make the yucky green appear more yellow than green. The color in this case is blue, surrounding it specifically a grayish, smoky, midnight blue. Basic blue, with a very slight hint of yellow, darkened with red, then lightened some with white, then blue is added to create a dark, smoky, blue-leaning, midnight blue. I disagreed from the moment he said the color needed pushed with that blue color towards the yellow. I felt my original color choice of golden yellow would be the best color to use against this to surround the yucky color, but this might be because I'm fond of green and drab green and subconsciously prefer a color that might bring out the green color. Anyhow, I thought the golden yellow color should go around the yucky green cube, as opposed to his blue color that he claimed gave the yucky color a more beautiful, rich yellow, golden yellow appearance. I don't think the surrounding color he chose brings out a yellow color at all. To me, it remains the same yucky color. I actually was a little put off visually by the combination of the colors. Maybe because the yucky green, smoky, midnight blue combination doesn't exist often in nature. Anyhow, I thought I would prefer the golden yellow background to surround the yucky cube, and I decided to test my theory. Color perception experiment. I knew I had to test my theory that golden yellow was a better color to use to surround the yucky green. So I actually created an image and tried surrounding the recreated yucky green color with the golden yellow color I was imagining. My results were impressive. See figure. The addition of the golden yellow color causes the yucky green color to appear to change to a darker, almost forest green color, which has an almost translucent shadow type effect. When you look at both boxes next to each other on different backgrounds, they actually look like different colors. How cool, yo! Here is where it gets interesting. Out of curiosity, I loaded the image into PIXLR and created a negative image. See figure. I had a theory that with the negative image the color blue might come into play. The results astounded me. You end up with 3 colors. The colors of black, blue, and specifically a shade of smoky blue, very similar to the color Merv said would bring out the yellow. It seems my theory might actually be the contrast to his theory, a contrasting theory on simultaneous contrast. Damn THA's sweet. But then I took it a step further. I added a filter to change the color of the squares, as well as the background. See figure. It changed the color of the cubes to a sort of Pepto-Bismol bismuth pink color, and the backgrounds to the colors red and a seafoam green color. I assure you the 2 pink squares are the same color, even though the one on the right appears darker. This figure will cease any doubt. See figure. So back to this figure. It obviously made me curious what the negative image would look like, so I made a negative image. The results surprised me. See figure. The negative image turned both squares from pink to lime green. Yes, the squares are both the same color, even though the one on the left appears darker, and the backgrounds changed from red to sky blue, and the seafoam green to a magenta type color nearly indistinguishable from the original color of the cubes. This was surprising. I then tried comparing background colors by using background colors next to a half-white image and its black negative counterparts and found it to be interesting. The backgrounds change in color and the color effect stays the same. The pink squares appear to be darker on the right side when in front of a white background, or a seafoam green background, or a black background, all darker on the right side, irregardless of background color. The green squares are a little different. The first 2 series appear to have the same effect and different backgrounds. See figure. The green squares have the same darker on the left and brighter on the right appearance, but the third series with white as the background color has an opposite effect of the lighter colored square on left side and darker on the right. Conclusion: our brains tend to prefer colors to complement and pull from other colors, but they might not be the colors you would expect to work the way you'd expect. I know, crazy, right? I even added a monochrome type gray filter and you still get the effect of the right square being darker than the left side.